Welcome back to the workshop for more properties of trees. So we have two properties for this video as well. A tree with n vertices has exactly n minus 1 edges. So when we look at a tree, we're interested in not having any cycles. And we'll talk more about that here in our next property as well. But essentially what we want to do is observe that if I had a collection of vertices, so let's keep it simple, let's say 4. If I wanted to connect them and have a tree, there are many ways that I could do this. I could connect these ones and like that and like that. And hey, look, 4 vertices, 3 edges. If I add any more edges, I'm going to create a cycle, so that would be bad. It would make it not a tree. If I take any edges away, again, it would be disconnected. All right, if I took this one away, right, it would no longer be connected. So yeah, I've got to have all of those things there. Excellent. Here we are. So let's take a look at another way of connecting them. Let's go across and like this. Isn't that good? Oh, no, this isn't actually connected. So I got to put one more on there. There we are, connected, no cycles, 4 vertices, 4 minus 1 is 3 edges, right? So we're observing, we're demonstrating that this does occur in these examples. Is this a proof? Is this an actual justification? No, in this case, we're just simply looking at a few examples of how it is in fact true. If I were to add another vertex here, I'd have to add another edge. So what we can do is we can actually observe using induction on the number of edges. So here's a graph with 1 vertex, there's 0 edges. Sorry, there's a tree here with 1 vertex and there are 0 edges. That makes sense. 2 vertices, add 1 edge to make them connected. Perfect. Tree with 2 vertices has 1 edge. Tree with 3 vertices, right? I can't add both of these edges, that would create a cycle. So I add an edge and say, hey, look, I have 3 vertices and 3 minus 1 is 2. 2 edges, excellent. Add a 4th, add an edge, add a 5th, add an edge, add a 6th, add an edge. So every time I add a vertex, I'm adding an edge. So it still holds true, okay? Because it's always 1 less. And the proof for this, a formal proof, would actually be done in a very similar way. It's actually proven by induction on n. So proof by induction does exactly what we were just looking at. It says, all right, it's true for the base case. And then if I add 1, it's true. And if I'm always capable of adding 1, then it's always going to be true. And that's exactly what we were trying to demonstrate here. Excellent. Our next property is that when an edge is removed from a tree, if we leave all of the vertices, the resulting graph is now disconnected or not connected. And if we have a graph that's not connected, then it's not a tree. And if we were to add an edge to a tree without adding any extra vertices, then the resulting graph has a cycle. And of course would not be a tree. So if I return back to some stuff that I've already taken a look at, let's just add in an edge. Hey, look, a cycle. So that's not going to work. If I were to delete an edge, now I would have a part over here and a part over here, and it would be disconnected. So that's not good either. Not a tree anymore. Let's go to our examples up here. If I were to add an edge, it would create a cycle. So that's no good. Delete an edge, it's disconnected. Over here, delete an edge, that vertex is going to stay, and we would have something that's disconnected. Add an edge, we have a cycle. Excellent. So this is that second property here, right? If you remove, when you remove an edge, it becomes disconnected. When you add an edge, you create a cycle. So, right, that's essentially the same sort of thing we were looking at right here. It has exactly n-1 edges. And these two properties are very, very closely related to one another, of course, because this is saying it has exactly this many edges. I can't add an edge. Can't add an edge because I'm going to create a cycle. I can't remove one. It's going to disconnect it. So of course it has to be exactly this, right? If I could add an edge, then this theorem here would not be true. Or if I could take an edge away, then this theorem here would not be true. So these are, of course, very closely related to one another. All right. So that's all I wanted to share for this video. So I'll see you guys back in the workshop very shortly for one more theorem that talks about some equivalencies in the properties of graphs. So see you in just a moment.